All right, ladies and gentlemen, it's my honor to introduce Sergio, or Sarge, since we're in Quebec. He's one of the best-rounded developers I had a chance to talk to in this conference, naturally because he's my buddy and we talk a lot. Fun facts about Sergio: he knows Morse code, he's a ham radio fan, and he plays a lot of classic guitars, so do not judge the fingernails on his right hand, he needs them to play. Sergio will be talking about programming the web like a game, which is something I'm really excited about. Take it away.
Thanks a lot. Okay, programming the web like a game. So this talk is about the programming model that we applied at the public search at mobile.de, and it's quite a catchy phrase and catchy title, but it's all serious stuff, so I promise. So we've been redoing the public search at mobile.de, and it looks like this. So it's all like a fresh design, and we have a new search backend, so we migrated from Voyager to Elasticsearch already, and yeah, it's all brand new. And we had a lot of heavy work underneath, renovating stuff. Apparently, as many other players in the industry, also have our monolith, which we would like to break with a code base like 8-9 years old, and introduce the same service architecture. Not too many, not too few. And we choose a stack that is not too far from the existing one, right? That means that we have a Java code base, we have the good old Tomcats serving our pages, so just to be on the safe side. And as already mentioned, there's a new paradigms also leaking into this new approach, move towards a 12-factor approach, so the whole new public search is completely stateless, is being used as one of the reference projects, being deployed on Docker containers, on the past stuff that Wojciech is going to show you. But like our biggest goal for this project is to have a KISS approach, keep it super simple. And the reason for that, this use case is one of our central use cases. So it's probably going to live for a while. And it's probably going to go through a lot of hands, maintenance. And yeah, the biggest goal we wanted to achieve is to have a simple code base, simply. So this is like a very professional overview of the system boundaries. And you have the public search, which our code name internally is PubSec. And you have a couple of services floating around the thing. So of course we have an advertising service providing personalized information for ads, a SEO service for search engine optimizations, and then we have the actual search, which we call the Unportal API, which is something like a domain-specific proxy towards Elasticsearch, such that you don't have to care about the raw Elasticsearch queries in the applications. And then we also have a couple of other services, which we call cold services. They are called cold services because they are not in the hot path of the request in flight. So they're being cached and only refreshed once in a while and serve just merely as data containers. So most of the logic apparently is outside of the public search. So how hard can it be to implement the thing? And that was also the assumption that we took when we started with implementing the thing here in the middle. So KISS, keep it super simple. So we essentially had literally code like you would find on any tutorial on the internet for MVC-based development. We had simple controllers, things you usually call service classes, invoked remote searches, JSON came back. We transferred the stuff back into objects, usually map-based objects, which we feed it back into the templating engine, which in our case is Google Closure Soy. So very simple, but we had problems with this attempt. Apparently, service classes are procedural, as you know. They don't abstract very well. It's a very anemic architectural model. So in our case, just merely like 1 month after development, we already had a code base that we didn't like anymore. So concrete concerns were spread all over the place, and I just have a little screenshot here of my own code, actually. So I was also part of the problem. You know, just to give you an idea, so just the concern of a price was spread all over different service classes, and it was very hard to keep track of what's going on and where. So the final verdict was the model is way too simple to move on, and we were not confident enough that this was a good code base that we would leave for other people to maintain and to have also as a nice showcase of good programming with a new greenfield application. So, yeah, that's me at the retrospective. And down there, this is Peter, one of the finest team leads I've ever been had the possibility to work with. And I'm blaming my own code base. So I think, we were just sitting there, you know what, guys, I mean, this is gross, the service classes, we should do something about this mess. So Peter was kind enough to split a few of us parallel in the development and to do a little bit of research on how we could, what things we could do better. And when you are in a situation like this, I mean, usually what you do, you blame the language, right? So, I mean, we do Java, and there's a few of Clojure aficionados who say, in Clojure this would be much better. And the Scala aficionados would promptly say, yes, if we would do this in Scala, this would be much, much nicer. And often these discussions are kind of fruitless, but in this case, something interesting happened. So Alex Tuom, I'm sorry for the beer. I didn't have a better picture. One of the most brilliant engineers I've had the honor working with had like an intuition. So he's a Clojure fan, and there is an editor written in Clojure. It's called Lighttable. Anyone heard of this editor? Hands up. Yeah, nice. So there was a blog post from Chris Granger, the author of the Lighttable editor, where he describes a pretty strange approach while developing the editor. It's a pure compositional approach, which is called ECS. He diverted it a bit, and he went away a little bit from the model, but nonetheless, I worked on it. I went into reading mode essentially, like for a couple of days, made a prototype, and well, this is what happened when I came back out of my rabbit hole. So we just rewrote the whole code while we were developing the public search. So yeah, programming is hard. Let's talk about games. ECS is an architectural style in the gaming industry, which was invented, I think the earliest references I found were like from 2000, like already like 15 years ago. These guys have been doing a lot of C++-based development in the gaming backends, and they apparently had the similar issues as we had. And it's quite amazing, but we have Java, we have an object-oriented language, and just take such a simple use case as an example like an asteroids game, where you have just simple ingredients like a spaceship, a flying saucer, asteroids, but also like maybe something a little bit more complex like static objects which do not move, or maybe some force wheels which enforce on you some gravitation. And it's quite interesting on what object-oriented models you can come up with. So this is one approach, right? So you have your object model, which are like the spaceship, flying saucer, asteroids, and they inherit maybe, this is just one approach of many, possible many approaches. They implement maybe a renderable interface, right? I mean, the spaceship has to be rendered on screen, so it has to know about how it is being rendered. So it implements methods for rendering. And the same is true for other objects. And all these objects are movable too, right? Whenever you grab the joystick and move here and there, I mean, they have to change the position. So maybe they also implement a movable interface. So they have all the logic inside to be moved around the screen. But there's like these strange things which already kind of destroy our little small hierarchy, right? These kind of strangers, like a force field, which is movable somehow, but is not being rendered on screen. On the other hand, you have these static objects, like a planet, which is being rendered on screen, but does not change its position. So it kind of becomes a little bit awkward with this kind of hierarchy. But nonetheless, it's maybe not too bad. It still has a relationship. Like all these guys delegate to a renderer class, which does the heavy lifting of doing and speaking to the graphics drivers, and a mover who does the heavy lifting of speaking to drivers of joysticks, mouses, and so on and so forth. And of course, we have patterns at our disposal. We read all the books, Gang of Four, where we can make this hierarchy a little bit easier. And this was just my simple attempt. So what does the bridge pattern tell us from the Gang of Four? Well, it says decouple an abstraction, and our abstraction is the asteroids game. That this is the thing that models our world from the concrete implementations. And the concrete implementations are the things that render stuff or move stuff, right? And then you have simple associative relations which connects those things, which the Gang of Four calls the bridges. So that's all nice, But you know what? You still have type hierarchies in here. Instead of having one type hierarchy, you now have 3 of them. And this becomes even more complex and even more of a hell to maintain. So we wanted to have something simpler. Maybe something that does not have any hierarchies at all. Maybe just pure composition. So a fresh start, and this is what the gaming industry came up, as I said, like 15 years ago, is like, do not use any object hierarchies. Just no superclasses, no inheritance. For the stuff that I just called renderers and movers, just use plain old data structures. I like to call them parts, right? It's not a plain old Java objects. They're like structs that you know from C programming, right? It's pure data, right? It's sets, lists, values, integers, floats, whatever is necessary. And then you have entities, and what we know from DDD is entities have an identity. So these are identity placeholders which are somehow associated with those data structures. And those relations, they have to be stored somewhere. And the place where those relations are being stored is what we call the world, which is kind of a nice abstraction. And the world you can consider a database of relations between components and entities. And then the last bit that is missing, where's the actual logic lift? Where's the actual logic lift that talks to the keyboards, to the mouses, and so on and so forth? And this is the place where systems come into play. So, a big fallacy to a big crowd of highly educated Java programmers is the components have no getters, no setters. They're pure data. So we do something that is very uncommon in the Java world. We do expose fields of immutable component types. And what? Oh my goodness, yes, object orientation is all about encapsulation. What a fallacy. But in the case of ECS, in the case of the architectural style of ECS, actually that's by purpose. These are only data structure holders, and you're not supposed to hide a get method in order to get to the data. The data is just there. And then the entity, this is literally the entity class that we also use in production. It's just an empty thing, and we use just merely the hash code of the object as its identifier, because we don't share objects between virtual machines. So this is good enough. And again, the entity is just an empty thing. There is no methods in there. You even cannot reach the components from inside. So what does the world actually do? So it stores those associations, and it's your interface to interact with those relationships. So for instance, you could say, hello world, give me all entities which have a component which has a renderable data attached to it. Right? Or hello world, create a new entity having a component with movable data. Or hello world, please update a given entity with a renderable component instance. So these are methods exposed through this interface. And this is how our interface looks like. It's essentially the whole thing. That's like the production-ready interface. You have a very simple method, new entity, where you give it a variadic argument of components. And then it returns you an entity, an opaque object, which you don't know what is inside. Essentially, there is nothing inside. But it has an identity, which is the most important bit. And then you can create or update a given entity once created with either a new component or an updated component state. So these things are modifying our world. And then you have other methods, essentially just for traversal. So this method gives you an optional component, an optional of C, for a given entity and a component type, which we express as a Java class. And then the mother of many, many combinators and functional aficionados will like this. We have a map method in the world implemented, which takes a component type and a function which gives you an entity instance, a component instance, and you can return an arbitrary type T of your liking and do stuff with it with a return stream of T. And we piggyback on this map method to provide a lot of helpers, a lot of traversal helpers for the systems in order to traverse nicely throughout the world. The systems, very simple interface, is essentially this, not only essentially, this is just copied from our real code base. The systems have only one method which they have to implement, and it's called apply, and they're given a world as an argument. And this is your interface to interact with the world. So going back to the example of the asteroids game, you could have an input system which has implemented the apply method. And then it could internally read and talk to all those USB devices and query the world for all entities that have a movable component attached to it and update it. On the other hand, you could have a rendering system which implements this very method, which iterates over all renderable entities or all entities that have a renderable component attached to it and puts them on screen. It's a very simple model. And the next thing you can do, you can build up a whole matrix of relations. Here you see on the x-axis possible component types in your application. So for a game, maybe you have a position component, sprite component, camera, and so forth. And you have systems responsible for either reading and or updating those components. And you can have many systems, and you can have them here on the y-axis. And there are quite some elaborate matrices, which I just showed you before. This is an example. This is Artemis. This is a pretty popular open source framework. I think it's pretty popular in the independent game developer scene. It's written in Java, and it gives you an ECS framework for developing games. And I liked it because they have this a generator where you have your systems, and they generate this matrix for you of relations between systems and components. So how the hell does this fit into a web application? This is just something completely different, right? But after a little bit of thinking, like after 2 days, I saw like a whole asteroids game on our web page. So where are the entities? For instance, we have this parameter area here on the left, which we call the Magellan. It's this area here. And you could, for instance, identify this field here could be a condition entity, right? Condition says whether a car is new or used. Or you could have a make model entity, which holds the data which makes a Volkswagen, BMW, and so on and so forth. And you can have other entities like first registration, price, fuel, and so on and so forth. So let's take this condition entity, and what components could be attached to this condition entity? Well, for instance, one component which came up is we call it the Magellan renderable. And this is a data structure which holds merely enough information, merely enough model data in order to be rendered here on the left side of the screen. On the other hand, a second component attached to the condition entity is, for instance, this here. We call it the Dutchman renderable. So this here is like a breadcrumb-like feature for our users. And this condition thing can be rendered on this Dutchman. And the Dutchman renderable holds merely enough data structures to be rendered on the Dutchman. And then all of a sudden, these components like literally came up naturally the more usages we had of the condition entity throughout the whole page. And apparently, we can also build a matrix of responsibilities in our system too. So we have a system which we call the request processor. And its sole purpose of existence is to take a request in flight, iterate through all entities which have a parameterizable component attached to it, see if any parameterizable has a value in the request in flight. If so, update the value. Once it's done, the request processor is finished processing. And then another system kicks in, which we call the API mapper, which iterates over all parameterizables that have a value set, and then updates another component of the very same entities, which we call the searchables, which have the information that is needed to invoke the remote search backend. And so you have this nice chain of responsibilities between systems. And of course, you have to maintain the invariant of a partial ordering of those systems, which we do in a configuration. So at the very end, you reach a system which we call the model generator, which also, the only thing it does, it iterates over components in the world and generates the final model in order to be rendered by the soy templates. And I did a prototype in 2 days, and it worked out extremely well. Like the whole code base looked all of a sudden very clean, and I didn't do any formal analysis of our domain, right? I didn't do any formal domain modeling, and trying to understand how the logical side of how the abstraction of our world works. I just had like a natural flow of programming and coded it. So we are live, and since last Thursday, we're live at 100% traffic, which is nice. Currently, we have around 40 systems in our code base, 50 entities, and 50 components. So it's quite some stuff. And the summary is, well, the model works surprisingly very, very well for us. The nice story is systems are short, to 82 lines of code average, with 95 percentiles of 150 lines of code, and I think the biggest system is 250 lines of code, which is not much compared to other classes I've seen in my life in Java code bases. So, and the systems are very concise, easy to read, and most importantly, can be tested in isolation. Since the only method they need to implement is an apply method, and the world is an interface, you can mock it very easily. You don't even need a mocking framework, right? Because you can use pure JDK proxies for it, or just instantiate a simple world by yourself. And what is also nice, since you can have those partial orderings of systems, for different use cases you can have different orderings. So you can have systems which are applied in different sets for different use cases. So for the main search, we have the whole shebang of systems that needs to be executed. But there is a hit counter endpoint, which only needs a subset of those systems. So and it's just a matter of configuration and the lower number of systems which need to be configured in order to implement the interface. And the same holds true for the world. Since the world's interface methods are exposed, we have simple wrappers, where we do tracing, logging, and it's very easy to debug the whole interaction between systems. So let's see if this works out. Maybe I can show you how we implemented the tracing. So this is the live site. And at the very end, you can, for instance, say end trace, which is an Easter egg. We will remove it, promise. I know, we're secure stuff. But if you do end trace, instead of receiving the search result page, you get a world event log. And what happened here? What I did, I implemented a tracing world, which intercepts all methods which are being executed on the world interface, on mutating and read-only methods, and sets up a log transiently in memory, which it puts itself, the trace, also as a component and as a new entity in the world itself, and exposes the whole flow of processing for this very request, for those very parameters that you just gave here. And this makes life very much easier. If something goes wrong, you have a Kibana entry, right? You have a 500 with a set of parameters in your log. You just copy paste and you look how the system behaves. And yeah, we made like this nice things where you see, okay, the request processor executed in line 157 the method create or update of the world interface on this entity with this parameterizable. So it makes debugging much easier, even on a live system, without setting up aspect-oriented programming, aspect-J agents, whatever. It's just, just by pure implementation of the interface. We currently are in the process of carving out the library of the application, and we use it already internally. It's called ECS Web. It's a very, very small library which can be used also by other web-based applications. It's also currently under legal review for open sourcing. But if you're interested, you can already use it now for your own web development. But be aware, there's a lot of different things done here. No getters, no setters, exposed public final fields. So be prepared for strong discussions with your dear Java colleagues. References, apparently I didn't find any references which implemented this architectural style in any web application. So we will find quite some blog posts on how to apply ECS in game developments. It's quite interesting to see how that just works because you will know how games are internally developed. I found one paper very interesting. I think it was written by a student, like an undergraduate student, but the paper actually is very nice and gives you a very nice overview on the ECS architectural style, like from a slightish academical point of view, which I find very nice. Yeah, thank you. In case you have any questions, just approach me and don't kill me for the missing getters and setters. Yeah, okay. Questions?